In this video, I'm going to show you how to solve the problem called understanding the qualitative predictions of the Arrhenius equation. Qualitative means without math, so that means that we don't need to actually do any calculations to solve these problems, but we are going to have to be thinking about mathematical concepts. The version of the Arrhenius equation that we'll want to use to solve this problem is k equals a to the a times e to the negative e sub a over rt. And in these problems, it's going to be giving us some information about one of the variables in this equation and asking us to make a prediction about a second variable. So the first scenario that I have here is telling me that the temperature is being raised. So the temperature in the Arrhenius equation is right here. The temperature is being raised, and it's asking me how this is going to change the rate of the reaction. The rate of the reaction is being expressed by K. So to solve this problem, the method that I'm going to take is I'm going to say, I'm just going to focus on the e to the negative e sub a over rt. I'm going to ignore the a feature right here. And I'm going to say if I have e to the negative e sub a over rt, and my temperature is getting bigger. So that means that my temperature is going up. If T increases, then that would mean that the term E sub A over RT is going to decrease because temperature is in the denominator. So if this number gets larger, then this whole entire term, notice I'm leaving the negative sign out, this whole entire term is going to get bigger. So maybe for this problem, we have a scenario where our starting temperature, let's say, when we do the math on all of this, it works out to be 1. So initially, maybe we have e to the negative 1. Again, I'm saying e sub a over rt is 1. Don't forget there's a negative sign. So maybe this is our starting scenario. And then as the temperature goes up, that means that this e sub a over our term is going to get smaller. So maybe this is going to go to negative 0.5. Something like that. And I understand that this is a larger number than negative 1. I'm just saying that e sub a over rt gets smaller. So I'm just comparing the 1 versus the 0.5. And then I'm going to work the math out on this. So I'm going to say e to the negative 1 on my calculator is 0.3. We're just going to go with 1 sig fig, 0.4. And e to the negative 0.5 on my calculator, that's 0.6. So what I have learned is that if the temperature goes up and this term gets smaller after all the math is done, everything is said and done, all of this actually ends up becoming a larger number, which means that the rate is going to increase. I think the word that's used in this problem is rise or fall. So the rate is going to rise. And in addition to asking you if the rate's going to rise or fall, it's going to ask you about how much relative to this 10%. Because this is an exponential equation, it's going to rise by not 10%, that would be linear, so more than 10% right there. So let's try that again, because this is a pretty tricky concept. Let's try it again with this one down here. And I'm going to rewrite my Arrhenius equation. K equals A e to the negative e sub a over rt. So in this one, it's saying that the activation energy, raise the activation energy by 10%. So the activation energy, which is right here, that's going up. And how will this affect the rate of the reaction? So again, I want to just start by focusing on the e to the negative e sub a over rt term. And this time, if e sub a goes up, then e sub a over rt is also going to go up. If we increase the value of our numerator in the fraction, then the whole thing will go up. So trying to translate this to the Arrhenius equation, including the e term and also the negative sign, let's say we're starting again, let's start with e to the negative 1. If e sub a over rt increases, then maybe our final number would be negative 2. Again, I know that negative 2 is a smaller number than negative 1. I'm just looking at e sub a over rt, not including the negative sign, so comparing 2 versus 1. And e to the negative 1, I already did that on my calculator. That was 0.4. Let's do e to the negative 2. E to the negative 2 is 1.1, positive 0.4. So we can see that increasing E sub A is going to have the effect of decreasing our rate. The word that Alex is using here is fall. The rate will fall. And again, it's exponential, so it's going to fall by more than 10%. 10% coming from this part of the problem.